You know, there's this invisible force all around us. It's what powers your phone, it's what heats up your lunch, and it's how light from stars billions of miles away reaches your eyes. It is literally an invisible universe of energy that our entire modern world is built on. So today, we're going to pull back that curtain and take a look at the incredible science of electromagnetic waves.
But let me just start by asking you a question. What could possibly connect something like sunlight, the Wi-Fi signal that you're probably using right now, and a medical X-ray? I mean, they seem totally, completely different, right? Well, it turns out they are all part of the same amazing story.
All right, let's jump in. Our story really kicks off back in the 19th century. Now, this was a time of huge scientific breakthroughs, and physicists felt like they had a pretty good handle on the laws of electricity and magnetism. But there was this tiny, hidden crack in the foundation, a little puzzle that just didn't quite make sense.
So here's what they knew for sure. A guy named Ørsted discovered that if you run an electric current, a flow of charge, through a wire, it creates a magnetic field around that wire. This was a solid, tested, totally accepted fact. It's actually the basic idea behind how electric motors work. Seems simple enough, right?
Well, this is where things get a little weird. Think about a circuit that has a tiny gap in it. In physics, we call this a capacitor. Now, current flows in the wire up to the gap, but no charge actually flows across that empty space. According to the law at the time, Ampere's law, you'd get a magnetic field around the wire, but nothing in the gap. And that just felt wrong.
And that was the problem. You had a real contradiction. Depending on how you looked at it, the law gave you two completely different answers for the same spot in space. In physics, that is a massive red flag. It meant the law as they knew it, well, it wasn't the whole story. Something important was missing.
And this is where our hero enters the story. Enter the detective in this scientific mystery, the absolutely brilliant Scottish physicist, James Clerk Maxwell. He looked at this puzzle and realized it wasn't a mistake. It was a clue, pointing to a much, much deeper truth about how the universe works.
Now, Maxwell was an absolute giant of 19th century physics. His real genius was taking all these separate, known laws of electricity and magnetism, laws discovered by people like Faraday and Ampère, and weaving them all together into one single, elegant, and incredibly powerful theory.
So what was Maxwell's solution? It was pure genius. He said, okay, even though no charge is flowing across that gap in the capacitor, something else is happening. The electric field in that gap is changing. And he proposed that this changing electric field basically acts like a current. He called it a displacement current, and that it also creates a magnetic field just like a real current would.
Now, this wasn't just some clever workaround. It was a profound discovery. See, physicists already knew from Faraday's law that a changing magnetic field creates an electric field. What Maxwell's idea showed was that the reverse is also true. A changing electric field creates a magnetic field. All of a sudden, the laws were beautifully, perfectly symmetrical.
And this newfound symmetry didn't just clean up the equations. Oh no! It led to an absolutely mind-blowing prediction. One that would, and I'm not exaggerating, change the world forever.
So get this. If a changing electric field makes a magnetic field, well, that new magnetic field is also changing, right? So it creates a new electric field, which in turn creates a new magnetic field, and on and on and on. It's this incredible self-sustaining dance between the two fields, each one creating the other.
And this dance isn't just sitting still. It's a disturbance, a ripple, that travels out through space, carrying energy as it goes. Maxwell's equations predicted that this ripple, this electromagnetic wave, had to exist.
But then, Maxwell did something even more amazing. He actually used his equations to calculate how fast these theoretical waves should travel. And the number that popped out of the math was just enormous, around 300 million meters per second. And here is the jaw-dropping moment. That number, 300 million meters per second, wasn't just some random speed. It was a number that physicists already knew very, very well. It was the measured speed of light.
The conclusion was just inescapable. It was revolutionary. Light itself, the very thing we use to see the world, is an electromagnetic wave. With one set of equations, Maxwell had unified electricity, magnetism, and light into a single, breathtaking theory.
But hold on, it gets even better. The theory didn't just explain the light we can see. It predicted that there should be a whole vast spectrum of these waves, most of which are completely invisible to our eyes, all traveling at the same speed, just with different wavelengths.
And this is that amazing spectrum. It goes all the way from super long radio waves that bring us music and TV, to the microwaves that cook our food, the infrared we feel as heat, and right in the middle, that teeny tiny little sliver of visible light that our eyes are tuned to see. Then you get to the higher energy stuff, ultraviolet from the sun, X-rays for medical scans, and finally, super high energy gamma rays. It's all the same stuff, just with different frequencies.
Now, this wasn't just some dusty old theory in a textbook. Once a physicist named Heinrich Hertz actually proved these waves existed, it kicked off a technological revolution that we are still living in today.
I mean, just look at the timeline. In the mid-1800s, Maxwell predicts it. Then, in 1887, Hertz actually makes radio waves in his lab, proving Maxwell was right. Just a few years after that, Marconi turns that lab experiment into long-distance wireless communication, and boom, the path to our modern connected world was laid out.
And now, we use this spectrum for everything. Take a microwave oven. It's a perfect example. It shoots out waves that are tuned to the exact right frequency to make water molecules shake like crazy. That shaking is heat, and it cooks your food from the inside out. Pretty cool, right?
And the list just goes on and on. Radio, your cell phone, GPS, the remote control for your TV, even medical procedures like LASIK and X-rays. Every single one is just us using a different part of the electromagnetic spectrum. It's truly the invisible infrastructure of our entire society.
Which, of course, brings us all the way back to that first question I asked you. What is the fundamental connection between sunlight, a Wi-Fi signal, and a medical X-ray? By now, you know the answer. They're all the exact same thing. They're all electromagnetic waves. Ripples in electric and magnetic fields, all zipping through space at the exact same speed, the speed of light. The only thing that makes one a radio wave and another an X-ray is its wavelength. That's it.
So think about it. It all started with a little puzzle, a tiny contradiction in a 19th century equation. And from that came a theory that uncovered a hidden reality and gave us the tools to build the 21st century. It really makes you wonder, what other invisible forces are out there, just waiting for us to find them? And what new worlds will they let us build?